Now, before it breaks, we reach a situation that the strain is no longer proportional to the stress. In other words, we abandon Hooke's law, as I will show you also today with a demonstration. The material begins to deform. It begins to flow in a way. And when you take the weights off, it will no longer have its original length. It will not return to the original length, but it will be much longer. And I will try to sketch you here what a curve of stress versus strain typically looks like. So here I'm going to plot delta L over L, and here F over A. So this is the stress, and this is the strain. In the beginning, you will see a portion that is linear. That's Hooke's law. And then, when you keep adding force, which we will do by gravity, we will just hang weights on it, then it starts to bend over up to a point here, which we call the elastic limit. And even though this portion is no longer linear, so even though Hooke's law no longer holds, still, if you take the weight off the wire, off the rod, it will still come back to zero. Once you are past this point, that is no longer the case. You will now see also that a small increase of stress will give a huge strain. So the rope will, the rod will get very long all of a sudden with a little bit of extra stress. And if now you were to take the weight off the rod, it would not come back to zero, but it would come back somewhere to here. So it's permanently deformed. And in general, the rod gets hot, and the work that you have done goes into heat and goes into the deformation of the rod. And so it goes like this, and then it goes like this, and here it breaks. At this value for F over A, which is that third column there, it will break.